This video is on maximum and minimums. Points where a function changes from increasing to decreasing has a gradient of 0. These points are known as stationary points and also local minimum or maximum. So on this diagram here, points A and C are local maximums and B and D are local minimums. You may also sometimes hear the term global maximum and global minimum, and the global is the actual highest point on the whole graph. So in this graph here, the global maximum would be right at the end, which I've just circled in orange because that's the highest point on the whole graph. And the global minimum I've just circled in pink, which is the lowest point on the whole graph that we've been given. At any local minimum maximum though, the gradient or the derivative will always be equal to 0. There are two ways that we can determine if a function has a maximum or a minimum. There's a second derivative test and a first derivative test. The second derivative test, we find we find the first derivative of the function, then we find the points where the first derivative equals 0. Then we find the second derivative. We then sub in the values we find in the second part, the turning points, into that, and then if the second derivative solution is less than 0, it's a maximum because it's concave down. If the second derivative is greater than 0, then it's a minimum because it is concave up. In the first derivative test, we find the first derivative. We then find the points where the derivative equals 0. To find those turning points, then we create something called a side diagram to find out if they are a maximum or a minimum. Both these tests work perfectly fine. A lot of the time people just choose the one that they find the easiest. Most people generally prefer the second derivative test, but what we do in the first derivative test does come in handy when we look at kinematics. Example 1, consider the function f of x equals 4 minus 3x squared plus x cubed for the domain of x being between negative 2 and 3. We want to determine any maximum or minimum points using the first derivative test. First thing we do is find the derivative, and when we do that we will get negative 6x plus 3x squared. Second step is we make this equal 0 because that will tell us where any turning points are, which will be our maximum or minimums. So from here we're just going to solve this quadratic. We can do this by factorising. And when we do this, we will find that x can be 0 or x will be 2. So that's where our two turning points are at 0 and 2. But we don't yet know if they're maximum or minimum. So that's now when we draw a nice little sign diagram. What we do is we draw a number line. We put on here our two turning points, which are at 0 and 2. Now also in the question, it tells our domain has to go between negative 2 and 3. So we also want those two values on the number line too. Now what we want to know is what is happening before and after our two turning points. Because if the gradient is increasing and then decreasing after a turning point, we know it's going to be a maximum. Or if it's decreasing and then increasing, we know it will be a minimum. To do this, we pick a number in between all these sections. So between negative 2 and 0, we pick a number. So I'm just going to go with negative 1. And it can be anything. Between 0 and 2, I'm just going to go with 1. And between 2 and 3, I'll go with 2.5. As I said, it can be any number between those two values. What we do then is we sub each of these numbers into our derivative because we want to know if the gradient is positive or negative. So I'm just going to put an arrow come up here. Our derivative was negative 6x plus 3x squared. So first of all, I'm going to put negative 1 into that. When you work that out, you'll end up with 6 plus 3, which is 9. Now, what the answer is isn't important. What is important is if it's positive or negative. So in this case, we've got a positive solution. So back on our sign diagram, I'm just going to write a plus between negative 2 and 0 because we know the gradient is positive between those two values. Next, the number that I chose between 0 and 2 we're going to sub in, which was 1. So the derivative at 1, which will be negative 6 times 1 plus 3 times 1 squared. Work this out, it will be negative 6 plus 3, which equals negative 3. Once again, the number doesn't matter. All that matters is if it's positive or negative. This case is negative. So between 0 and 2, the gradients are negative, and then we do between 2 and 3. And I just went with 2.5. So negative 6 times 2.5 plus 3 times 2.5 squared. So that will equal 15 plus 18.75 when you work that out. And so our total is 33.75, which is positive. So between 2 and 3, our gradient is positive. Now we analyse the sign diagram. Between negative 2 and 0, the gradients were positive, which means it was increasing. Then between 0 and 2, it was decreasing, so the graph was going downwards. And between 2 and 3, it was going upwards. So that tells us here, if we just look at the shape, it was doing something like this. Okay, then when x equals 0, that is the maximum. And then when x equals 2, that was the minimum. Now the question does ask us for the maximum minimum points, which means we do need the coordinates. So from there we can just sub 0 and 2 back into our original equation to find out the y coordinates. And when we do that, we'll get that when x is 0, the y is 4. And then when x is 2, at the minimum, the y would be 0. And that's the points of our maximum and minimum. Second example, determine any maximum and minimum points using the second derivative test. So with the second derivative test, first thing we do is find the first derivative, which would be 2x minus 3x to the power of a half plus 1. The second step is we want to find where the turning points are, so we make this equal 0. When you solve this, we'll end up just finding that x would equal a quarter or x would equal 1. Now with the second derivative test, we then want to do the derivative again. And if we do this, we'll end up with 2 minus 3 on 2 x to the power negative a half. Once we have that, we want to sub in our values that we found in step 2 into the second derivative to find out if it's concave up or concave down, and then we'll know if it's maximums or minimums. So we're going to put a quarter in first. We'll put a quarter into 2 minus 3 on 2 multiplied by a quarter to the power of negative a half. That will give us an answer of negative 1. And then we're going to sub in 1 into the equation too, which would be 2 minus 3 on 2 times by 1 to the power of negative a half, which gives us a solution when you work this out of a half. Now from here, once again, we're just looking if they're positive or negative. So because in this situation here, negative 1 is less than 0, it means it is concave down, which means it is a maximum. And then with the 1, this 1 a half is greater than 0, which means it's concave up, which means it is a minimum when x equals 1. And once again, if you want to then find the points, just always read the question to see what answer they're wanting, sub those values back into the original equation, and you'll get the coordinates of those 2 points. And that's maximums and minimums.